Hey you guys, today we're going to talk about common and natural logs. A common log is just a logarithm with a base of 10. So when you see log of x, that means log base 10 of x. It's like how when an exponent is 1, we don't write the 1, we just know it's raised to the first power, or with a square root, we don't put the 2, we just know it's the square root. If you see a log without a base, then that means the base is 10. There's some rules for common logs, and they're very similar to the basic logarithm rules we talked about the other day. The log of 1, or log base 10 of 1, is 0 because 10 raised to the 0 power equals 1. The log of 10 is 1, and that's because 10 raised to the first power is 10. The log of 10 to the x is the log base 10 of 10 to the x. So it would just be x, right? Because 10 to the what equals 10 to the x. 10 to the x equals 10 to the x. And then 10 raised to the log base 10 of x, and that would just say log of x would be x. Because the base and this are the same, remember exponential and logarithmic functions cancel each other out. So this one would actually just look like 10 log of x, and that would equal x. All right, let's do some examples with these common log rules. All right, for the first one, we have the log of 100. So remember, 100 is just 10 to the second power. So if you think of log base 10 of 10 squared, that would just equal 2, because 10 squared is 10 squared, right? And then 10 to the log of 33. Remember, this is the exponential and the logarithm cancel each other out, so it would just be 33. The log base 10 of 10 to the 7th would be 7, because 10 to the 7th is equal to 10 to the 7th. All right, the log of 1,000. So we're doing the log of 10 to the 3rd, because 10 to the 3rd is 1,000. So 10 to the what equals 10 to the 3rd, that would be 3. And then 10 to the log of 53, or 10 to the log base 10 of 53, the log and the exponential would cancel out, and that would just be 53. And I'm just applying those properties that are rules that we just talked about. All right, next is the natural logarithms. And a natural logarithm is a log with a base of e. And remember, e is Euler's number, right? And when it's a natural logarithm, we use ln. I know you want to think NL. I don't know why they did LN. Okay. So when you see ln of x, that really just means the log base e of x. So let's look at the natural log rules. The natural log of 1 is 0 because e to the 0 equals 1. The natural log of e is 1 because e to the 1 equals e. The natural log of e to the x is x because e to the x is equal to e to the x. And e raised to the natural log of x is just x because this exponential and logarithm cancel each other out. So let's do some examples using the natural log rules. So for the first one, we have the natural log of e squared. Remember, that's the same thing as the log base e of e squared, so that would just be 2. E squared is equal to e squared. E to the natural log of 5 would be 5, because the exponential and logarithm cancel out. All right, this one's a little fun. You got the natural log of 1 over e to the 6th. And with it being on bottom, if I move it back up to the top, the numerator, that would be e to the negative 6. So the natural log of e to the negative 6 would be negative 6. All right, the natural log of e to the 9x, again, would just be 9x. E to the what is e to the 9x? E to the 9x is e to the 9x. And then the last one, e to the natural log of 125. You have this exponential and this log with the same base, so that's just going to be 125. It's the same logarithm rules, you're just changing it for these new bases. Well, that's it for today. I hope you have a wonderful afternoon.